Hello all, I welcome you to this YouTube channel, and today what we'll be looking at is how to achieve a loop-free network, particularly if we only have switches that are interconnected. In other words, if you have a layer 2 network and you want to make sure that there is no loop and there is also redundancy, then STP is the way to go, Spanning Tree Protocol. Before we go into the configuration proper, I also want to let us know there is an enhanced STP known as RSTP, Rapid Spanning Tree Protocol. And the difference between the traditional STP and RSTP is that RSTP converges faster than STP. Also, for RSTP, the condition of the ports is 3, while that of STP is 5. For RSTP, the state of the ports are as follows: you have forward, you have learning, you have discarding, while that of STP are forward, listen, learn, block, and disable. So we'll be using MikroTik devices, and by default RSTP is enabled on MikroTik. Three parameters that you also need to familiarize yourself with when you are deploying RSTP in a layer 2 network are as follows: the priority of the bridge, the priority of the port, and the port path cost. I would like to repeat myself that you need to familiarize yourself with 3 parameters when implementing RSTP in a layer 2 network, particularly when you are making use of MikroTik devices. And the parameters are as follows: the priority of the bridge, the priority of the port, and number 3, the port path cost. Those are the 3 parameters. Now, for us to implement RSTP in our topology, we need to first choose a root bridge, and the root bridge will be the one that has the lowest bridge priority. And for the sake of this our topology, we are making switch 1 to be our root bridge. And from what we can see, we have like a ring like topology on our screen, and this can even cause loop if there is misconfiguration, if the cables are not properly connected, and if by any chance somebody tampered with the way the setup is being designed. And once there is a loop, it can flood the MAC address table, and it can also affect the performance of the CPU, which can even lead to the bringing down of the entire network. So how do we now set up the root bridge? Let's go into the configuration proper now. So I'll go to my switch 1. I'll create a bridge. Let me give it the default name by MikroTik, which is bridge 1. I'm using the command line for this setup, purely CLI. So just 0 is in hexadecimal, so we'll give it this value. So by this, I have made my switch. No, this is switch 2. Let me remove this configuration. To do that, just remove 0. So that has removed the. So this is my switch 1. Bridge, add name, bridge 1, then priority. So for switch 2, the same step, but the priority will now be different. My priority, I can make it to be in hexadecimal format 2000, and I'll go to bridge switch 3 as well. These 3, the same command across. Bridge 1, the name, and the priority as 3000. For switch 4, priority will be 4000. So after this, I need to add ports to the bridge that was created. Now we need to watch out for something for switch 1. Let's go back to our screen. We have ETA 2, ETA 4, ETA 3 and ETA 5. So for switch 1, I'm going to set the port priority only on the root bridge. We are not going to set the port priority on other switches, but we are going to do it only on the root bridge, which is switch 1 in our own case. Please take note. So we enter into the bridge and the port, add the bridge, which is the one that we created, and the interface, which is, we are starting with ETA. Let me go back to the ETA 2, 3, 4 and 5. ETA 2, then I can give the priority of 20 in decimal, and I repeat for ETA 3. ETA 4 as well. And ETA 5. ETA 3, 2, 3, 4, 5. So after I've created the port priority on the root bridge, the next step, let me go to the other bridges and just add the port to the bridge. So for switch 2, we are only adding ETA 2, ETA 4 and ETA 5. No need of setting priority. Let this ETA 1 come up here. Let me switch 1. ETA 2, 4, 5. That was created with 1, and interface that will be ETA 2, ETA 4 and ETA 5. We go to switch 3. This switch 4, let me just add the switch 4, ETA 4 and 5. Interface, bridge, ports, add, bridge. Okay, for ETA 4, we are going to choose path cost for ETA 4. That's the only difference. Remember, on the root bridge, because what we want to achieve is traffic to flow from switch 1 to switch 4, because we have the opinion that our switch 1 has a device connected to it, and we want to reach the other end, which is switch 4 that has another device connected to it. So on our switch 1, we will have our priority on the ports, while for the switch 4 that will have another end device connected to it, we're only going to define the path cost for the ports. So going into that, add bridge. Let me first configure ETA 3, switch 3. Switch 1, switch 2. I need to find switch 3 on the screen. Where is switch 3? 1, 2, 3. Yeah. So let me just add ports, add on switch 3. We have 3, 5 and 4. 3, 5 and 4, 3, 4, 5. 1. Interface 3, 4 and 5. So 3, 4, then ETA 5. So for switch 4, we are only having ETA 4 and 5. So we are going to be defining path cost for those. Add So path cost here, add. Then you have our bridge. So the bridge 1. And interface. We have beta 4 and 5. Beta 4. So you can make the path cost. Everything is hexadecimal, beta 40. Oh, sorry, I'm on switch 3. I need to be on switch 4. So that's why you have to be very, very careful when you are doing your configuration. So for switch 4, to beta 4 and 5. Interface beta 4 and the path cost. Let's make it 40. Let's add it at 5. Let's have our path cost to be 50. So after this, we now do our verification. And to verify, let's choose a VLAN ID. Let's configure a VLAN across all our switches. So starting from switch 4, let's set a VLAN, interface, add, name, let's call it test. Let's give an ID to the VLAN. Let's give it 100. On which interface? Let's attach bridge 1. So we're going to span this VLAN on all our switches. So it's already on ETA 4. We need to add it to it's already on switch 4. We need to add it to switch 3 as well. Interface VLAN, add name equals test, VLAN ID 100. Then it will be on the bridge interface, which is bridge 1. The same thing for switch 2 and switch 1. We are permitting the VLAN through the network, since we want to reach it from switch 1 to switch 4. So that's will pass through switch 2, switch 3 before getting to switch 4. You can vary the name, but the VLAN ID must be consistent, because we're only running one instance of VLAN for this our configuration. Is bridge 1. So we've already we are almost getting to the end. So the next step that we need to take is to verify, test across. Since we are testing from switch 1 to switch 4, so let me just attach an IP to that VLAN on switch 1. To do that, we go to the IP address menu. Let's give it 192.168.10.1. No, we'll give it 10.10. Which interface? On our VLAN interface, which is test. So let's go to switch 4 and give it IP address, add address 192.168.10.40. Which interface? On our VLAN interface. Now can I reach the management IP on switch 1? So it's going through. So now we want to see, maybe we have a redundancy on our network. So if you look at our topology, from switch 4 I can reach switch 1. If I disable ETA 5 on switch 1, let me disable it from switch 2 and see, maybe the ping will still go through. Where is switch 2? This is switch 2. Where is the ping? This is the ping. So let me disable interface points. My interface is 4. So go to the interface menu and I'll say disable number 4. So you can see that the ping is still responding, which means that it's no longer passing through this path. It's no longer going through ether 5 to switch 2 to reach switch 1, but it's now using switch 3's ether 4. Now if we disable switch 3's ether 4, will we still have the test running, our ping test running? So on switch 3 I want to disable ether 4. Let me bring up switch 3. Let's disable ether 4. Let me get the number first. Ether 4 is number 3. Interface disable 3. What's that? So you can see that our redundancy has been taken off, because both ports that should give us the complete that should provide the redundancy, the main and the backup, has been taken off. Definitely there will be no reachability across. So let me enable back. You can see that our ping has started responding. So if you follow this configuration and you implement it as directed, definitely your network will be free from loop and you also have redundancy. We could have disconnected any of the ports to show. We could have disconnected ether 4, ether 2, any of these from any of the sites to actually prove if the redundancy across. So with these steps that we have taken, we have ensured that our layer 2 network is free from loops and there is a redundancy. Thank you for staying through to this period. I want to appeal to us that we like, we share and we subscribe to this YouTube channel. This will go a long way of growing the channel. Thank you one more time. I'll see us in the next video.